Hey guys, so this is number 8, 9, and 10 on the Mira Lab. That's what this video is about. So this section is about investigating how some evidence that DO equals DI. All right. So let's start by measuring DO. That is, you're gonna remember this from shadows. Distance of object. DI is distance of image, okay? So this is the object, okay? Now, this is called a normal line. It's from point A to the mirror, and the line is 90 degrees. You see that? 90 degrees to the surface of the mirror, okay? So we're going to draw two more normal lines. We're going to draw one for B and one for part C as well, okay? 90 degrees to the mirror, 90 degrees to the mirror. You could do this on your paper as well, all right? Now, if you printed it out, you're going to have the same distances that I have. So I'm going to measure basically DO 3 times. DO is the distance of the object, I should say, distance of object from mirror. Okay, so that's DO, and that's DO. And we're going to do it 3 times. So, like I said, if you print it out, you're going to get the same numbers I'm getting. I'm going to try and be really precise, and you're going to see why afterwards, and you should measure it out exactly, all right, just like I do. So I got 6.1 centimeters. That's DL. Here, I'm getting 2.5 centimeters. And for letter C, I'm getting 5 centimeters on the dot, 5.0 centimeters, okay? Now our rule is that the distance of the object from the mirror is the same as the distance of the image behind the mirror. Okay, DO equals DI. So what I'm going to do is take this 6.1 and behind the mirror I'm going to measure 6.1. I guess I ran into my words a little bit. That's okay. 2.5. Well, I'm going to measure 2.5 behind the mirror. I'm going to remeasure that 6.1. There we go. And letter C, I'm going to measure 5 centimeters from basically wherever I stopped my mirror or held my mirror at last time. Okay, so those are my dots for A, B, and C. Now I'm going to connect those together to make a triangle. You should do the same on your paper. Looks like the same triangle to me, except reflected over. It's like a reflection in math class, sort of, okay? So this is 6.1, 2.5, and 5.0. Go ahead and write that on your paper, all those same measurements. But those are DI, the distance of the image, all right? So let's get our semi-transparent mirror out, and I could show you guys what you would see if you had one, at least, is if we hold it right on where I measured DO2 right here. I'm going to take this down. I'm going to show you how cool that looks. Alright, so look at that. And it falls right on top of it like that when you put the mirror right there. That proves that DO equals DI because you could literally see it in the mirror, okay? Pretty cool.